Hello students, welcome to Academic Aura. Today we begin with practice set 1.2 of the chapter Similarity. Now see the first question. Given below are some triangles and lengths of line segments. Identify in which figure ray PM is the bisector of angle QPR. We have to identify in which figure ray PM. Okay, everywhere the same thing is given, whether ray PM is the bisector of QPR. Okay, now first understand this. Suppose a triangle is given. Suppose this is a triangle and this is an angle bisector. Okay, so the ratio of these two sides, okay, the ratio of these two sides, if BD is the bisector, if it is the angle bisector, okay, then AB upon BC, okay, the length of AB upon BC, the ratio of AB upon BC is equal to AD upon DC. The ratio of AB upon BC is equal to, it is equal, okay, so both these sides will be equal to AD upon DC. This is by angle bisector theorem. Okay, so now see the first one. First what we will do is we will write whatever is given. Solution. Write down whatever is given. Now see here what is given here. PR is equal to 3, QM is equal to 3.5 and MR is equal to 1.5. Write down whatever is given. You can write given over there. Next is we will use angle bisector theorem. Okay, we will use that. We will see whether we are getting both the sides equal. Okay, if both the sides are equal, then we can say that PM is the bisector of angle QPR. So first what we will do is we will take this side. PR upon PQ. PR upon PQ. We will first take these two sides, PR. Okay, the ratio of these two sides, PR upon PQ. Right? Don't write PR. Write PQ. PQ. Write the longer one first. PQ upon PR. Okay. I had written the smaller one. You can write the bigger one first. That is PQ upon PR. Write that. Now PQ. See, PQ is given 7 and PR is given 3. Now this you cannot reduce to the lowest form. You can keep it as it is. That is 7 upon 3 only. So this is your first one. Okay. Now see the second one. We took this PQ upon PR. Now we will take this side where the angle bisector, okay, intersects at this point M. So we can take these 2 points. We can take QM upon MR. QM upon MR. QM is 3.5 and MR is 1.5. Okay, this QM upon MR. Now see here, there is a point after one number, and in the denominator's place also there is a decimal point after one number, so that you can remove that point. You can get 35 upon 15 here. Okay, remove that point, you will get 35 upon 15, because on top in the numerator's place and in the denominator's place we have the decimal point after one number, so we can, that gets cancelled. Now see, it becomes 35 upon 15. 35 upon 15 we can reduce in 5 times table. 5 3s are 15 and 5 7s are 35. So here we get again 7 upon 3. See, here also we got 7 upon 3. So this is your second one. Now, so what we get, this is equal, both are equal. Here also we got 7 upon 3 and the right hand side is equal. So we will write these two, PQ upon PR. Therefore, PQ upon PR is equal to QM upon MR. And from where we got this? From 1 and 2. Okay, so therefore we have to say, so whenever you get these two sides equal, okay, the left hand side and the right hand side is equal, so we will say that by converse this ray PM is the bisector of QPR. Whenever both are equal, we will say ray PM is the bisector of angle QPR. So we can say that therefore ray PM is the bisector of angle QPR. Okay, and you can give a reason here by converse of angle bisector theorem. Okay, so whenever it is a bisector of angle QPR, give a reason by converse of angle bisector theorem. These two sides have to be equal, then only it is the bisector of QPR. Okay, now same way we will do the next one. Now see, in the next one you can write whatever is given. Suppose if I am writing it here, PQ is equal to 10, PR is equal to 7, QM is equal to 8, and MR is equal to 6. All this is given. Okay, so now what we will do is we will take these two sides. We will take the ratio of these two sides, that is PQ upon PR. We will take these two sides. Okay, PQ upon PR is equal to, what is PQ and PR given? PQ is 10 and PR is 7. 10 and 7. Suppose this is your first one. Okay, the next one will be, now see the next one. We took PQ upon PR. Okay, now we will take QM upon MR. QM upon MR. Now see what is QM. QM is given 8 upon MR is 6. So when we reduce this, 2 3s are 6, 2 4s are 8. We get 4 upon 3. This is your second one. Now see the first and second. Here we had got both equal. Both were same. Here we haven't got it equal. Here it is 10 upon 7 and here we have got 4 upon 3. That means PQ, write this again, PQ upon PR is not equal. It is not equal. When it is equal, put the equal to sign, but here it is not equal. So say that PQ upon PR is not equal to QM upon MR. Okay. So therefore we can write that ray PM is not the bisector. Therefore ray PM is not the bisector of angle QPR. Okay. Now see in the third sum. Now you can see this first. We can write whatever is given. You can write this. PR is equal to, PQ is equal to, PQ is equal to 9, PR is equal to 10, QM is equal to 3.6 and MR is equal to 4. Okay, after writing all this is given. Now what we will do is, the first thing we will take, we can take this PQ upon, we can take PR upon PQ, PR upon PQ. See here, PR upon PQ, and write down their values. PR is 10 upon PQ is 9, 10 upon 9. Okay, PR upon PQ, 10 and 9. Now see here, we cannot reduce this, so keep it as it is. This is your first one. Okay, the next we will take is MR upon MQ. Okay, the next one we will take is MR upon MQ. MR is 4 and MQ is 3.6 here. Okay, now see here, this is 4 and this is 3.6. Now what I want to do is, I want to remove this point, so I will multiply on the opposite side, that is in the numerator I will multiply with 10. Here I will multiply this number with 10. In numerator 4 I will multiply with 10. So we get 4 tens are 40 and here we get 36. Okay, there was a point after one digit over here. So one digit, so you put 1 0, that is 10. So 4 tens are 40, and this we have removed the point, so it becomes 36 here. Now 40 upon 36, 40 upon 36 is divisible again in 4 times table. 4 tens are 40, 4 nines are 36. Again here also we got 10 upon 9. This is your second one. Okay, now see here, both the sides, the left hand side and the right hand side are equal. Okay, we can see that the left hand side and the right hand side are equal. So we will say, therefore PR upon PQ is equal to MR upon MQ. Okay, PR upon PQ is equal to MR upon MQ from 1 and 2. We get this from 1 and 2 when both are equal. Okay, now you can see this, both are equal, so we can say that PM is the bisector, ray PM is the bisector of angle QPR. QPR. Okay, ray PM is the bisector of QPR since both the sides are equal. Now see the second sum. In triangle PQR, PM is given 15. Okay, PM we can write here, PM is 15, PQ, the whole thing, this whole thing PQ is 25, PR is 20, this whole thing is 20, and NR is 8. Okay, this is given. Now what is the question? State whether line NM is parallel to side RQ. We have to state whether NM is parallel to RQ. So now here we will use basic proportionality theorem. Suppose you have a triangle like that, and if a line is parallel to it, you say A, B, C and PQ. Okay, if this line is parallel to BC, okay, if line PQ is parallel, if PQ is parallel to BC, okay, then we can say that AP upon PB is equal to AQ upon QC. Okay, this is by basic proportionality theorem, that is BPT theorem. If PQ is parallel to BC, if it is parallel, then we can say that AP upon PB is equal to AQ upon QC by basic proportionality theorem. Okay, now see here, state whether NM is, we have to state whether NM is parallel to side RQ or not. Now this we can do it by converse of basic proportionality theorem. Okay, converse of basic proportionality theorem is the reverse. We can say that first we can say if AP upon PB is equal to PQ upon QC. Okay, if AP upon PB is equal to AQ upon QC, if both the sides are equal, then we can say that PQ is parallel to BC. Okay, reverse. Then we can say that it is by converse of basic proportionality theorem. Now first see, whatever is given, we will first find out these sides, because see, this part is not given, PN is not given, and here MQ is not given. Okay, here we don't have PN and here we don't have MQ. So first what we will do is we will find out those two sides. Okay, so what we will do is, now first we will take PR, take this side, PR is equal to, how is PR formed? The whole thing, this line, PR is equal to PN plus NR. PN plus NR. Okay, PR is formed by PN plus NR. We can write here P dash N dash R. P dash N dash R. Okay, that means the three points are in a straight line, they are collinear. Now PR, how much is PR? This whole line is 20, is equal to PN. PN we don't know how much it is, we have to find, and NR is 8. Okay, keep this 20 as it is, get this 8 over here, is equal to PN. So therefore PN is equal to 12. Now we got the value of PN, we got it 12. Okay, PN we got 12. Now same way we can find out this MQ, the same way. PQ is equal to, we can say PQ, the whole line, PQ is equal to PM plus MQ. We will write here P dash M dash Q. Okay, this whole line PQ is equal to PM plus MQ. Now put the values in it. PQ, the whole thing is 25 here. PQ is 25. PM is 15. And MQ we don't know. So keep it as it is. Okay. Now here 25 will be as it is. 15 bring it over here. On the left hand side will become minus 15 is equal to MQ. 25 minus 15 will be 10. So therefore MQ is equal to 10. So this MQ value of MQ we got 10. Now we have all the values. Okay. Now we will see. First we will take Pn upon Nr. Okay. First we will take Pn upon Nr. Take this side first. Pn upon Nr. Pn is given 12 upon 8. Now when you reduce this in 2 times table, in 4 times table also you can reduce. 4 2s are 8 and 4 3s are 12. So here you get 3 upon 2. Okay. Suppose this is your first one. Now see, we took this side. Now we will take this side. Pm upon MQ. Pm upon MQ. Now see Pm upon MQ. Pm is 15 upon 10. 15 upon 10 we can reduce it in 5 times table. 5 2s are 10 and 5 3s are 15. Here also we get 3 upon 2. This is your second one. Okay. Now what you do is, see, here also we got 3 upon 2 and this side also we got 3 upon 2. Okay. So that means LHS is equal to RHS. Left hand side and right hand side are equal. Okay. So when both the sides are equal, we can say that Pn upon Nr. Okay. We can say that Pn upon Nr is equal to Pm upon MQ. We will say, okay, Pn upon Nr is equal to Pm upon MQ from 1 and 2. Okay, from 1 and 2. Both are equal. Now we can say that line, both are equal. So we can say that line NM, therefore line NM is parallel to side RQ. Okay, it is parallel. Why? You can give a reason. By converse of basic proportionality theorem. By converse of basic proportionality theorem. Okay. Now see the third sum. In triangle MNP, NQ is the bisector of angle N. Okay. NQ is the bisector. Now these values are given. Mn is 5, Pn is 7, MQ is 2.5 and we have to find QP. That means we have to find QP. Now when they have said, we can write down this first. In triangle MNP, in triangle MNP, NQ is the bisector. NQ is the bisector of angle N. Okay. In the first part I told you that if this NQ is the bisector, if it is the bisector, we can use angle bisector theorem. That means we can use this. Pn upon Nm, Pn upon Nm you can use. Okay. So Pn upon Nm is equal to PQ upon MQ. We will say by angle bisector theorem. Okay. We took Pn upon Nm. Okay. Pn upon Nm is equal to PQ upon Qm or MQ. Now see, you can write down the values Pn and Nm. Pn is 7 upon Mn or Nm is 5 is equal to PQ. We don't know. We have to find PQ or QP, whatever it is. We can also write, instead of PQ, you can write QP because we have to find QP. So instead of PQ, you can also write QP upon MQ. MQ is 2.5. Okay, so now we can cross multiply this and find out the value of QP. Cross multiply this, that is 7 multiplied by 2.5 upon 5. Okay, 7 multiplied by 2.5 upon 5 is equal to QP. Now we can reduce this. So 5 ones are 5, 5 5s are 25. Okay, 5 ones are 5, 5 5s are 25, 7 5s are 35. There is a point after one number. So therefore QP is equal to 7 5s are 35. But there is a point after one number. So we can put a point over here. Okay, so we get 3.5 since there is a point here. So we can write 3.5. There is no unit given. You can, if you want, you can just write units. So QP, find QP. We got QP is equal to 3.5 units. Okay, now see the next sum. Now see the next sum. Measures of some angles in the figure are given. Measures of these angles are given. You have to prove that AP upon PB is equal to AQ upon QC. Okay, so first what we will do, we can prove this by basic proportionality theorem. Okay, first we can say that PQ is parallel to line BC. We will prove that PQ is parallel to line BC. And if these two lines are parallel, then we can say that AP upon PB is equal to AQ upon QC. Okay, now see what is given in this figure is these two angles are given 60 degrees. So we can write those two angles. Angle APQ is equal. Both are equal, so write equal. Angle APQ is equal to angle ABC is equal to 60. Okay, both are given 60. So we will say angle APQ is equal to angle ABC is equal to 60 degrees. That is given. So right there, given. Okay, now if these two angles are equal, that means we can say that these two angles are congruent, and you can see they form corresponding angles. These two angles form corresponding angles. So first we will say that angle APQ is congruent to angle ABC. Okay, they are congruent. So we can say they are because by corresponding angles. Since they are corresponding angles, they are congruent, they are corresponding angles. So since they are corresponding angles, we can say that PQ is parallel to BC. Line PQ is parallel to line BC. Now since we have proved that this line is parallel, PQ is parallel to BC, so now we can take this AP upon PB. So you can write therefore AP upon PB is equal to AQ upon QC. AQ upon QC. This is what we had to prove. Okay, first we proved that line PQ is parallel to line BC. When they are parallel, then we can use basic proportionality theorem. AP upon PB is equal to AQ upon QC. Okay, so this is what we had to prove, and we got, and you can give the reason by basic proportionality theorem. Okay, so we have finished the fourth sum. Now see the fifth sum. Now in the fifth sum, in a trapezium ABCD, this is a trapezium. AB is parallel to PQ is parallel to DC. You can see these are three parallel lines here. Okay, we have three parallel lines here. AB is parallel to PQ is parallel to DC. Okay, suppose whenever you have three parallel lines, see here, these three parallel lines, and this is the transversal, these two are the transversals. So by this property we can get, okay, these three are the parallel lines and these two are the transversal. Okay, so what we get is AB upon BC is equal to PQ upon QR. Okay, so whenever you have three parallel lines, okay, parallel lines and it's transversal, the property of, this is called the property of three parallel lines and they are transversal. These two are the transversal. So we get AB upon BC is equal to PQ upon QR, and you can give the reason by the property of three parallel lines and their transversal. So same thing we are going to use in this sum, in the fifth sum, and find out BQ. Okay. So first of all, in the figure you can write down whatever is given here, or you can just write it over here. I'm writing it in the figure itself. Suppose AP is 15, AP is 15, PD is 12, BQ we don't know, they have not given, we have to find BQ, and QC is 14. Okay. So first we will say that the lines are parallel. Okay. We will say the three parallel lines which are given. Side, we can say side, see it's given here, side AB is parallel to side PQ is parallel to side DC. Okay. Side AB is parallel to PQ is parallel to side DC. When we have three parallel lines, what we get is AP upon PD. Therefore, AP upon PD is equal to BQ upon QC. BQ upon QC. What I told you, we get this by the property of three parallel lines and their transversal. By the property of three parallel lines and their transversals. Now we can write down their values. AP, see AP is given 15, PD is 12 is equal to BQ, we don't know, we have to find BQ. So BQ, write it as it is, and QC is 14. Okay. After writing that, we can cross multiply this. That means 15 multiplied by 14, and write this 12 here in division. Okay. Is equal to BQ. Okay. Now what you do is, you can reduce this. Now suppose if I take this in 2 times table, 2 6 are 12, 2 7s are 14. Okay. 2 6 are 12, 2 7s are 14. This and this we can reduce in 3 times table. 3 2s are 6 and 3 5s are 15. Okay. 3 2s are 6 and 3 5s are 15. Now what you do is, now we cannot reduce, so we will keep this. 5 7s are 35 upon 2. We get 5 7s are 35 upon 2. Now this 35 upon 2, if you divide, 35 divided by 2, 2 1s are 2, 2 7s are 14, 2 5s are 10 here. So you get 17.5. So therefore BQ is equal to 17.5. So this is what we had to find. BQ is equal to 17.5. Okay. BQ we had to find.